Good morning, everybody. So I got a question through about one of the tutorial questions from tutorial 3. In particular, is tutorial 3, part 2, question 5G. And the person asking wanted to know about how we go about solving part G. So if you remember, this question is about the attendance in tutorials for 2 different courses. And through the first, 6 parts, we calculate the tutorial attendance in one of the classes, which we find is 40 cos pi t over 30 plus 63, and in the other is 30 sine pi t over 30 plus 45. And the next question is, what is the overall attendance? So if we add together the attendance of these two, well, clearly we can add those together. The total tutorial attendance, is simply the addition of these two, which is 40 cos pi t over 30 plus 30 sine pi t over 30 plus 45, and 63 is 100. Okay. And the question here asks, can we write this function, so this is tutorial attendance as a function of time, can we write this in the form of a sine kt plus alpha plus a constant? Okay, so can we take this function here, and can we find a value of a value of k, a value of alpha, and a value of c, such that this function is equal to that function? Okay, so I'm going to work this off, and let's see if we can do that. Okay, good. So what we want to find is an a k, an alpha, and a c, such that the left-hand side here is equal to the right-hand side here. And again, what do? We think of pattern recognition. So on this side, we see that we've got a cosine and a sine with some coefficients in front. And here we've got a sine of the addition of 2 values, kt and alpha. Okay? What do we think about here? Well, we know something about sine a plus b, where a and b are 2 angles in the middle. Okay? So what do we know here? Well, we know that this is sine a cos b plus cos a sine b. Okay? So somehow we can write this thing here in this form using this identity. So let's actually do that precisely. I'm going to rub this off and then we'll write this out. So we get, so now we can write this is a sine kt cos alpha plus cos kt sine alpha plus c. Okay. So now they're looking a little more similar. It's not really exactly what we want. Actually, let's put the a separately in front of each of these. So I'm just going to multiply through here by a. So we've got a sine kt plus times cos alpha plus a cos kt sine alpha plus c. So in fact, already we can kind of see that these terms here look a little bit more like these terms here. So this term here, we've got a sine kt. So this term here looks a little bit like this. Here we've got a sine k, well, we don't know what k is yet, times t. And here we've got sine pi by 30t multiplied by 2 values here. And here we've got this term, which has a cos kt, and it looks something like this here. Okay. And then finally we've got 108, and we've got a constant here. Okay. So straight away we can equate the c with 108. Okay. C equals 108. So if we make c equal to 108, then this expression here is already looking quite a bit like that expression here. Okay. So now let's actually equate this with this, and this with this, and see what happens. Okay. So we're going to take this, so we're going to say we want a sine kt cos alpha, and we want this to be equal to 30 sine pi t by 30. Okay. And we also want a cos kt sine alpha we want this to be 40 cos pi t over 30. Okay, so now we've got two equations, and here in fact we've got, well, it looks like we've got an unknown here, an unknown here, an unknown here. So it looks like we won't be able to do this, because generally if you've got three unknowns, a, k and alpha, you need three equations. However, by looking at the structure of these equations, we can already get an idea as to what k might be. Okay, so let's drop this off and see what happens. Okay, very good. So I've just taken what was below and I've written it again up here. So again, we want to say how can we calculate, or how can we fix a, k and alpha such that the left-hand side becomes the right-hand side. So the only place that we see a t on the left-hand side is here, multiplied by kt, and the only place we see it here is on the right, pi t over 30. Therefore, for these two to look even more similar, we can fix k in both cases to be pi by 30. Pi by 30, k. So now in both cases we're going to have a sine pi by 30t. Here we've got an a cos alpha, 30 equals 30, and here we've got an a sine alpha, which is going to be 40. Okay, so we're going to fix now a equals pi by 30. Okay, now we fix two of the constants. Okay, but if this is sine pi by 30t, then we can cancel that with that. They're the same thing now. And if this is cos kt, it's cos pi by 30t, and this is cos pi by 30t, we can cancel that and that. So now we've got two simpler equations. Now we've got a, we've still got the cos alpha, alpha equals 30, and we've got a sine alpha equals 40. Now we've got two equations, and we've got two unknowns, a and alpha. Now again, we think, what do we know about trigonometric functions, cosine and sine? Well, one thing that we know is that, so we know for an angle, any angle, theta, cos squared theta plus sine squared theta equals 1. Okay. So what should we do here? Let's square both sides and add them together. So we can square this, we can square this, we can square this, and we can square this. And now let's add them together. So if we add the left-hand sides together, we're going to end up with a squared, and I'm going to simplify it as we go along, cos squared alpha plus sine squared alpha equals 30 squared plus 40 squared. Okay. But we just said cos squared alpha plus sine squared alpha, because of this trigonometric identity, is 1. So we have a squared equals 30 squared plus 40 squared. Okay. So in fact, we know from our Pythagorean angles that 3 squared plus 4 squared is 5 squared, and similarly, because 10 squared is 100, which itself is a perfect square, we have 50 squared is 30 squared plus 40 squared. Okay. This tells us that a is equal to 50. Okay. Okay, so we've just found now that a is 50, so we've got 3 of our 4 constants. So let's write that down. This, a equals 50. Okay, so we've got our last constant to find, and the last constant is alpha. Okay, so what do we have there? Well, here we're going to use another trigonometric identity, very simple identity, which is that sine alpha divided by cos alpha is tan alpha. Okay? So in fact now we can take the non-squared version of this, so the original version of these two equations. Let's remove the squared here and here, here and here, and now let's simply divide this one by this one. And when we do that, we see first of all that the a's cancel, and then that we end up with tan alpha on this side. So tan alpha, so this is this equation, this the left-hand side of this equation, divided by the left-hand side of this equation. So this is tan alpha equals 40 divided by 30, which is 4 over 3, which tells us that alpha is arctan 4/3. Okay, and we're done. So let's write that here. Alpha equals arctan 4/3. And now what can we do? Now we can put these back into the original formula, and we can write that the attendance, tutorial attendance is equal to 50 sine pi by 30 t plus arctan 4/3 plus 108, and we've managed now to get the tutorial attendance into the form that was asked for in the first place. So it looks like this. So again, we used a little bit of pattern recognition. We used the idea that we have sine of two things added together to remember that we know something about an identity related to sine A plus B. We got that we had relationships between cosine and sine, and we knew two simple identities there. We saw that there was a linear, a constant term at the end of both of them, and we could equate those, and we got that, and so eventually we got the final answer. Okay, so let me know in the comments if you have any questions, but I hope that clears it up for now. Okay, very good. See you all soon.